There we go. Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. I'm really liking chat right now, by the way. Sorry, Ep.022. I have links blocked at the moment. Yeah. So I've spent the last week or so, maybe a little more, thinking about how I'm going to get software onto my MSX machine. A little context about this really sexy MSX machine. I would hold it up, but it's actually just better to pull up a picture because it's all plugged in. And the lighting is not great here. Plus, I've shown this picture so many times, but I just love this. Love how this thing looks. This is my beautiful MSX machine. I absolutely love how it looks, which is why I bought it. And yeah. Sexy, sexy thing. One of the reasons I got an MSX machine is because there was a couple people in the demo scene that want to do a demo on this. And I'm kind of interested in learning a new piece of hardware, so I thought this would be fun. And so I went ahead and bought this. One of the nice things about, yeah, this is Beauty and the Beast. That's exactly the relationship that's going on here. Just trying to make her fall in love with me. Is that how that story goes? I've never actually seen that movie. A lot of the silverware in my house doesn't sing though, so I'm not sure about that. Anyway, one of the nice things about MSX is that it uses 720K floppies, which is a standard. It also follows a lot of like Windows conventions, like there's actually a basic interpreter on here rather than like a DOS prompt. But rather than autoexec.bat, it'll just run on startup, this will run autoexec.bas if that's on the disk, which is kind of funny. Stuff like that. It's just kind of funny how similar and slightly different everything is. But the reason I bring up the disk drive in particular is if you have something that can write 720K disks, double density disks, this will read it. So my idea was I was going to buy a USB floppy drive, and I did. And the thing couldn't write basically anything. It's kind of useless almost. It turns out it's really picky for the formatting on the actual disks. It's not a very good. Yeah, it's just not very good at all. So I was thinking about how I would actually get software on here. So I looked at a couple things. I looked at CryoFlux, which is one thing that, particularly if you get an old floppy drive and you have a CryoFlux, you can do things like write Amiga disks, which are kind of weird. Skeleton, how glorious is that thing's keyboard? Actually, it's pretty great. If you ever felt a C64 keyboard, or actually an Amiga keyboard, because the Amiga ones are a little nicer, so they're a little clickier. It's kind of like that. It's a little bit spongy, but not too bad. I mean, it's springy. It's just a cheap mechanical 80s keyboard, and it feels quite nice. But yeah, so the disk drive was kind of useless, but I was thinking about other ways of getting software onto it. Yeah, Amiga stuff is weird. Trying to regain my train of thought here. So what I realized is that, okay, if I have another PC, like an older PC that has a floppy drive header on the motherboard, then I should be able to like run Linux on it or something and make this little sort of disk writing station, which would be nice. Skeleton, you can type on my keyboard anytime. Totally not lewd. Totally platonic. This is setting up to be a good stream. So what I realized is that I asked my colleagues and stuff, and just to see if any of them had machines with floppy drives in them. See if I could get this stuff on the cheap. I also looked around at like fin.no, which is kind of like our Craigslist out here. And it's saw a couple deals that were okay, so I made some arrangements to go look at them. But then during the week, one of my colleagues came in with a let me pull this up. With a Compaq ProLinea 575. And let me pull up this image here. Okay, that didn't work. Hold up. Oh, this thing's so ugly. It's so ugly. And I need to find one that shows it proper. Here we go. Compact ProLinea 575. And this is just it's a big machine. I have it over here. Again, you can't see it. It's behind a couple screens, and it's exactly, Nobi. It's thick. Oh, I love this stream. So the thing is that it didn't have a disk drive. It didn't have a hard disk. It has Ethernet, ironically. But this is a Pentium. This is a Pentium 1, 586, with 32 megs of RAM. Runs at 75 megahertz, hence the 575, like Pentium, 75 megahertz. And the issue with it is that because it didn't have a hard disk, I couldn't actually boot anything that wouldn't fit on a floppy, and I only have 720K floppies. So this kind of presented a bit of a problem. What I ended up doing is I ended up getting an IDE to SATA adapter and buying a new SATA disk to try and put in there. And I figured, okay, if I couldn't get that to work, at least I get another disk out of it, which is nice. Turns out I didn't get it to work, and here's why. The BIOS on this machine, and this is actually, I haven't actually seen this before. The BIOS on this machine has this like split BIOS thing where like a small portion of the BIOS is in memory on the motherboard, and then a larger portion of it, which contains like the menus and the configuration utilities, is normally on a hidden partition on the hard disk. Now, because I got this without a hard disk, I didn't actually have that partition, so even if I got software onto the hard drive, I couldn't actually get it to boot from there unless I remade these utilities. Now, HP bought out Compaq some time ago, so all the links to where you would normally get the disk utility that would build these disks are all dead. But if you search in the HP support site, you can actually find the utilities for this. And I did, but it's like 4 megabytes. And that's not going to fit on any of my floppies. So my plan was to get like DOS or something, boot it on the floppy from the floppy drive, because I had one disk that I could actually write. This is actually kind of cool. Of all the disks I have, most of them are brand new and like unformatted, and the USB drive I have is just shit at formatting disks. But I have this one disk that we got from Revision. It was part of our prize pack for PC64K, and it's called the Cure, which is ironic because it's totally solved my problem. For some reason, this floppy disk drive could actually, like, I could get block access to the disks so long as the disks were DOS formatted, which is super weird because the block access can overwrite the MBR on the disk as well, and then the disk drive is useless with that disk again. But it would allow me to get the first of the 3 DOS 5 setup disks onto there, which contains format.exe. So I was actually able to format some other disks, get a full DOS install disk set, use that to install DOS onto 4 other floppies, and then, so then I had the full system. Now, I tried what I was going to do is boot into DOS that way and then install DOS on the hard disk, but no matter what I tried, I could not get this old machine to read the new hard disk, even with the proper adapters. So what I'm going to try to do is the same colleague actually has an IDE drive laying around. So I'm going to see if I can get him to bring that tomorrow and see if I can actually get that to work instead. And that adapter I bought is bidirectional, so I should be able to get the IDE drive into my main PC, which only has SATA. Hopefully, like, format it and stuff there and see if I can get it to boot. When I get that working, then I'm hoping to use DOS to fire up that disk building utility that I mentioned for the Compaq, because, of course, that requires 16-bit OS to run. So, of course, it's bootstrap. That's exactly what this is. Just like, what can I hobble together here to just get the right bytes on the right disks? Anyway, all of this, again, was to get software onto the MSX, and I ended up coming up with a fairly simple setup that just requires a bit more disk swapping that I'm happy with. Skeleton, that's awesome. I would love that. So the setup I ended up with is, so I mentioned that I got those DOS installed disks, and then I was able to install DOS onto some other disks. So now I have it set up where on that DOS installation, you can actually set up a RAM disk, or a RAM drive it's called, but I call it a RAM disk because that's what's called elsewhere. And the RAM drive will emulate another drive in memory so long as you have enough memory. And in this case, 32 megs of memory is actually quite a lot for DOS 5, so that's actually quite useful. So what I've done is I've set it up so that I can boot into DOS onto that machine. And then, so when it starts up, it'll fire up the RAM disk, and it's got like a 16 megabyte RAM disk. And then it also copies a disk copy utility onto that RAM disk. From there, I'm able to take a DOS formatted floppy that's 720K. I can put a 360K disk image onto that on my PC via the USB floppy drive. Then I can bring that over to the DOS machine. I can load that disk image into the RAM disk. And then I can swap floppies to my target disk and use the disk copy utility to copy the disk image from the RAM disk onto the target floppy. And from there, I can put that into my MSX and it totally works. It also goes the other way as well, where I can do the imaging and then, yeah, bring that back to this machine. Yeah, exactly, Sophia. So that was kind of convoluted, but the solution ended up being a bit simple. Of course, a lot of this would have been a lot simpler if I had actually gotten a hard drive that worked. Yeah, so it does have Ethernet. Again, I can't boot off, like I can't talk to it at all right now because I can't read and write the hard drive, which means I can't get into the BIOS configuration utility to rewrite the BIOS to get it to boot from something else, nor can I boot from anything else other than the floppy drive because it can't find that partition. And no one has imaged that partition as far as I can tell online. So yeah, I totally didn't think about that until like earlier today, localhoster, that I totally could have done like all of this in VirtualBox. But I totally did it with actual disks on the actual machine. I'm proud of that. So what I'm hoping is if I can get a proper hard drive on there, then I can do my original plan, which is run some like super light Linux and then just build a tiny program that's just going to sit there on the network, and then I can send disks over to it or pull disks from it. I think technically I should be able to do that if I can find the right driver for DOS, which there may be one if there's like some generic DOS Ethernet driver. I might be able to clear off some other like the unused utilities on that DOS disk and maybe still be able to pull that together. But I don't really want, the reason I want to do Linux particularly is because it's easy to write software for Linux. It's easy to configure a compiler, or at least relatively easy for 586 rather than doing the whole stuff or like 586 targeting Linux rather than it is for like 586 targeting DOS. Unless I download some super old software development package, but I kind of rather not do that. Might be Arch Linux or just damn small Linux. I ended up trying Elks on there because it would actually fit on a 720K floppy, but it didn't have DD, so that was kind of a necessary thing. I may be able to actually pull that together though. And I also didn't know what to do to test the network setup from there, but would be worth a shot. But I don't know. I think there's Microcore is another one that looked really nice. Just because of how little RAM it had. You'd actually be surprised at how many of the really small Linuxes have large memory requirements these days. FreeDOS would probably work from floppies. But yeah, for right now, I got enough of a system going with what I had, and I'm super thrilled about that. And then if I can get this IDE drive to work, then I'll be able to get something a lot better, I hope. But it is pretty cool to have a 586 or Pentium that I can actually do this with. So I'm fairly satisfied. Anyway, that's been my week/weekend. Mostly yesterday. Other than actually getting together some of the hardware and buying a bunch of the cables, which I did throughout the week. But the reason I bring all that up, now that I can get software to and from my MSX, I want to start writing code for the MSX. I want to start making some effects, and that's why this is called Messing with MSX, and has the label Demo Effect Coding. Now, to be fair, Demo Effect Coding may be a little bit misleading because I don't know how far we'll actually get. All I've done so far after that was just start setting up a basic development environment. So while transferring a bunch of these floppies and trying to figure out what works and what doesn't, I figured out, like I said, that autoexec.bas thing was one of the tricks that I figured out. So what I've done here, I've made this MSX Playground repo. I'm going to link this publicly. Or sorry, link this in the chat because this is a public repo. And all it has right now is just a license, a README. There's a script here and a couple other things. So what I've done is I've set up an emulator called OpenMSX. Let me pull up the website to this. OpenMSX, I don't really know what's like a good MSX emulator, to be honest, because I'm not that familiar with these machines. But OpenMSX seems to be quite nice. Seems to be recent development, at least fairly recent compared to some of the other ones. It has a lot of configuration options. One of the interesting things about MSX is that it's really a hardware platform rather than a specific piece of hardware, unlike something like the C64 or Atari VCS or something. And the reason why that's particularly interesting is there were a lot of different manufacturers and there were a lot of different configurations of the hardware. So an MSX emulator has to actually be pretty open-ended. It has to support a fair amount of different pieces of hardware and then be very configurable about how those pieces of hardware fit together. So you kind of have to configure the emulator to the specific hardware you have. Now, the nice thing about this is it comes with a ton of these XML files, which are for different systems, and they totally had the system that I have here. But the other thing, not only do you need like the hardware configuration, like which pieces are in this hardware, you also need to tell it, okay, what is the ROM for this particular hardware? In this case, there's a system ROM, and a basic ROM, and a disk ROM that it all needs. And to get those, you either pirate them from something, which not condoning, but that's one of your options. Or you can actually read them from your own machine. And it turns out some guy, I can't remember where I found this. It's probably just on some fact somewhere. But some guy actually published a tool to sit there and read out the ROMs and just write them to a disk, which is pretty cool. So using this convoluted disk setup earlier today, I made a disk image using some utility, and then I put his thing on there. I transferred the disk image to a disk onto my in fact it's which disk is that? There it is. Put it on this disk. So it had his ROM utility, ran it in the MSX, dumped the ROMs. It was super easy. It's like the perfect utility. First it lists which ROMs are there, and then you can dump them. Pretty nice. Reverse the process to then image this disk into memory and then put that on my transfer disk and bring it back over here, and then go in my disk utility and pull off those ROM files. So now, the cool thing about that too is that the way that this identifies ROM files that go with a particular machine is it uses these SHA-1 hashes, which is really nice because then I could just put my ROM files in there and it would work. So this one matched, so I got these from my own machine. This one did not because it's the disk, and typically like disk ROMs will not match because a lot of them are actually register configurations and newer or older versions or just like slightly different drives, whatever. So I ended up just adding my own because what this will do is you can have multiple definitions and it'll just loop through all of them until it finds one that it likes. With all of that, one second. With all of that, I was able to configure the emulator to literally boot my machine. So that's literally what my machine does when it boots up. It shows that screen. It's pretty awesome. Hey, Lilac Simtex. And boots straight up into BASIC. I don't think there's a disk in here. We can do fun stuff. I should have just done print stuff. I don't actually know how to stop this in the emulator, so I'm just going to shut that down. But yeah, so I got that working. And ended up being fairly simple. There's a couple scripts things that it takes. It uses actually TCL scripts to configure stuff, which is really cool. Yeah, it totally, that little sparking sound when you hit the keys, that's on the real hardware, which is awesome. It's actually, there's a in here. I think it's this one. PPI, I think, is because the reason I think this is related to the input is because it has some stuff like JPJS is a keyboard type, all the stuff, ghosting, kind of locks, all that stuff. And yeah, it has a sound in the volume of this. So I think I think that's actually what this value is in this this hardware configuration file, which is so cool if that's what that is. But it totally does do that click on the real hardware too. I noticed that when I was firing it up. And I've actually been a little bit worried because I don't actually have a 100 volt transformer for Japanese electronics. I only have a 115 volt one for American electronics. Now, a lot of this stuff, if you look at the schematics for these, that's okay because a lot of the stuff will just take a transformer down to some reasonable voltage, and then they'll have a bunch of regulator circuits after that that are usually rated for like 35 volts or something when it's been transformed down to like 7. So they're usually fine, but they might run a little hot. So in this case, this one does, and I don't run it for long periods of time until I can get a proper transformer, which I've ordered, but I'm waiting for it in the mail. But I'll run it for short periods of time, and the reason I bring that up is because I originally thought that little click might be related to that, because it does a funny thing where if I'm like formatting a disk on here and it's running for a couple minutes, it will actually heat up to the point where the disk drive will start whenever it moves the motor, the graphics on screen twitch. Little sketchy, so I'm not doing that very often, but yeah. Yeah, the kana lock, there's like English letters on the keys, and then there's Japanese kana as well. So that's what the kana lock is. I think I closed the picture of it, but yeah, pretty rad. But I'm guessing that's also how this emulator knows which LEDs to show on screen. So you'll notice when I pull this up, it's got a bunch of LED indicators here showing you the different ones. So it also has pause, turbo, and that kind of stuff. It's just, this machine's awesome. So once I got the emulator set up, then I started working on the on my little development environment. Now, so far, all I have is a make file that will build a disk. So I can do make test here, and it will build a disk and then test it in the emulator. Now, the disk file, currently it only has this autoexec.bas, which will probably just print hello world. Yeah, there it is. And so again, all this is doing is this is just a basic file. So this will contain ASCII characters for a basic program, exactly like I would have typed in just now. MSX, by the way, is a standard that was made by both Microsoft and the ASCII Corporation. So you can expect Microsoft line endings with ASCII encoding in these files. But yeah, it'll if there's a disk in the drive on startup, it'll just look for something called autoexec.bas. If it's there, it'll load it into memory and execute it. That's all I actually know about how this machine executes code. So it'll be interesting to find out some more of that. The make file is just as straightforward as possible. We make the disk, and then we test with the disk using the emulator. Now, again, the emulator uses these TCL scripts, and particularly to make the disk, we also use OpenMSX, this emulator. It's actually pretty cool. The script context that it has actually has a bunch of very useful commands, in particular this one called disk manipulator. So we can actually create the disk with the same software, just using a different script. And that's pretty rad. Just import different files onto it. So the whole thing is just super simple right now. Now I really want to drop into assembler as soon as possible. Skeleton says the words of both worlds. I'm assuming that's related to the encoding and line endings that I mentioned earlier, in which case I totally agree. But yeah. So yeah, I want to get into assembler as soon as possible, but I don't really know anything about how this machine boots. So I figured I'd just go through that on stream. And that might actually be somewhat interesting. But yeah, so far I'm fairly impressed with this OpenMSX thing. It seems to be pretty cool. I'm quite thrilled that my hobbled together disk setup actually works, and I was able to dump my actual machine ROMs via that mechanism. Pretty happy about that. The disks that I have actually work, which is cool. So yeah, right now I'm just satisfied that things work. And then I got to learn how to actually make use of all this. So yeah, that's where I'm at. How are you guys doing? Oh man. By the way, there's this MSX Resource Center, msx.org. Awesome resource. Like, everything is here. I'm just super impressed by all this. Like here I can go to MSX hardware. Here's different computers. MSX2 computers, and I can go find mine, which is the HB-F1XD, which, where is it? Where is it? There it is. Oh, such a beauty. By the way, I totally got it with the box. The box is awesome. Sophia, glad to hear you're doing well. Skeleton, unfortunately, you're not doing as well, but hope that improves. Yeah, particularly this has this programming section of this wiki. Localhoster says, I like how the open MSX thing gives you utility similar to how VirtualBox does for the most part. Yeah, that's just really useful because, like, if you have an emulator, emulating certain things, especially a disk drive, is super useful. Vice does the same thing, the C64 emulator. In fact, in Makeshift, we use that to not build the disk image that we use for release, but to update the disk image with the latest of the demo file. The reason why we didn't build it is because it actually emulates a 1541 disk drive. It's called C1541. It emulates a 1541 disk drive with the firmware that's normally on the disk drive, and that firmware doesn't allow you to write files of the same name multiple times, which we actually use for like separators if you look at the disk listing. So we actually can't write the disk using that utility, but we can like replace files. So that's kind of funny. So I really like when emulators do that, at least, of course, where appropriate, like in this case where you'll actually want to do stuff with disks and things like that. So it's really nice when you only have to really put that one tool in your path. Especially for stuff like this where that tool's open source, because in a lot of cases you'll find like specific like disk authoring tools and stuff that are you only get builds for Windows, or you have to build them yourself. So it's especially nice when it's part of a cross-platform emulator that they include that as well. Oh, come on, I read how to detect MSX hype. You can just watch my stream. Might find some MSX hype there. Hey, Ko, glad to hear you're doing well. Working on 1-bit graphics and watching Ferris. Ice cream next. That sounds... I like how that sounds. Although I don't like watching Ferris. It's just weird. Also, I'm jealous of the sunny weather because it's just been super gray and dull here. Although, on the other hand, great excuse to sit inside and play with a Pentium, so that's pretty nice. Also, I don't know if I've shown this on stream. This is something I made a few years ago. It's called FartOS. And this actually was totally useful yesterday in just testing that I could get block access to a disk and just write the simplest bootloader possible. This is my own OS that I wrote a few years ago. All it is a bootloader. It's just made in assembler here. And it brings you to this prompt, and no matter what you type, it just says Dave sucks over and over again. So like every key press prints another letter of this message, and it'll just repeat. So yeah. Also, Dave totally doesn't suck. Dave's an awesome guy, but he was staying with me at the time, so thought that'd be pretty cool. Shoutouts to Dave. He totally doesn't watch these streams, but yeah. But anyway, yeah, that actually was super useful to just build that little bootloader and then put it on the disk to see if I could boot something before trying to boot something more complicated. Pretty awesome. Nah, it's not a 2001 Space Odyssey ref. Not quite. Creekbot sounds exactly like what I was looking for in my main OS. Good. Feel free to try it. It even has localization options where you can, during the build, customize what the name is. That was contributed by Kuzma, by the way, if you guys know who that is. So there's really cool stuff here about how to like detect the MSX type. Reading address 2D from the main BIOS. How to detect VDP type. VDP is the different video chips here. Cool code for that. But I want to set up an assembler. Now I'm pretty sure any anything that'll target Z80 is going to work. And I particularly tend to like WLADX, which is listed here, particularly because I use it for a lot of other platforms, or at least have used it for other platforms before, I should rather say. Like when we did the Kefren's bars, I was using that. When I did my old Game Boy demo a few years ago, I did that. So I tend to like to use that because it has like the same syntax and stuff. But I have no idea how like the memory mapping is going to be, or I'm guessing what'll happen is we produce a binary file and then use BASIC to load that and execute that into memory. But I don't really know where that would go in memory, and I don't really know how to lay that out. So I'm going to have to find some guide here or something. Oh yeah, sorry, Sophia. I have links blocked because I do emulator stuff, and I don't want people to post nefarious things, I should say. Yeah, OSDev seems like a really great resource for doing that kind of stuff. I kind of wanted to take that further, but it very quickly becomes like quite tedious. But the first stage loader was kind of fun. Alkama, you're nothing but scrap oxide. Yes, that's totally a Rust ref. There was, I think the original message from Nightbot was you're nothing but scrap metal. And I made it oxide because Rust. There's also C compilers here and stuff, but I don't want to do that. There's going to be some like Z80 specific stuff. And eventually we're totally going to want to look into some of this. Not really. Don't really need to know about the file formats, I think. No, I want to go straight to assembler with this thing. System variables code and hooks in RAM after boot? What is that? Oh, nice. This is actually good to know. Although, as soon as we get control of the system, we're just going to trash this, so. Because, so the interesting thing is we don't just do, like, we're not going to, the system is not going to boot into our code. We're going to go through the MSX operating system here first, and then it's going to run our program. So I need to figure out a little bit about how that works, rather than just dive into like the Z80 boot process or something. Yeah, who needs a BIOS anyway? Exactly. Yeah, a few words about the machine's video and sound capabilities. To be honest, I don't really know. In fact, this wiki actually, this says developing for MSX. Just add some more on this, I guess, but let's find some stuff here. Yeah, I still don't have a sub button. I need to look into some stuff for there, or for that. If it were just as simple as me turning it on, I would have done it. But with me sitting here in a country of which I am not a citizen, there's some things I need to look into before I do that. Let's see. MSX2 system is what we're working with here. So MSX has a bunch of different sort of like versions of the platform, I should say. So there was the original MSX, which I think these even had years next to them, which was introduced in 83. MSX2 is 85, MSX2 Plus 88, and then MSX Turbo R. Now, particularly the machine I have and what I'm going to be targeting here is the MSX2 standard. Let's see what that's got. Main RAM at least 64K without a memory mapper. Many MSX2 have its internal RAM extended with a memory mapper system. My particular machine, it has 64K of main RAM. It's actually a little bit unfortunate because a lot of the demos that have been produced for this in the past require 128K main RAM. But that's how it goes. 32K basic / BIOS ROM and 16K sub ROM. So that's those are the ROMs I pulled off there today. Video display is a Yamaha V9938, which is backwards compatible with the video chips that were in the previous MSX standard, which is kind of cool. But generally, let's see what we got here. That's got on itself 64 or 128K of RAM, or 192, interestingly. Didn't know that, actually. Silicone porn. My particular model has 128K VRAM. In fact, it makes a point of that whenever it boots. Says it here. I think that's kind of funny. Got a couple text modes, 80 by 24, 40 by 24, or 32 by 24. Resolution 512 by 512, 4 or 16 colors from a palette of 512. 256 by 212, which will be 16 colors out of a palette from 512. Or probably a palette of 4 or 16 out of 512 possible. Is probably what that means. Not actually sure. And then I guess there's a 256 mode by 212 with a 256 color palette. 32 sprites, 16 colors each, max 8 per horizontal line. It actually has some harder routines for copying, doing like block copies, doing lines, filling buffers, which is usually it'll do like take each memory location and then XOR and write it back to the next memory location. Do that over and over again. Typical XOR fill. Some logical operations on all of these for how it writes it back. Interlacing for double resolution and a vertical scroll register, which means it'll be able to move the graphics up and down like this. It doesn't actually have a horizontal one, but it does have a screen adjust, which is normally meant for the user to adjust, like center it in their display, but I think I'm going to probably end up using that for some scrolling stuff. That's kind of funny. So that's all I really know here. Skeleton, no worries. That's fine. I don't mind. I appreciate it, in fact. For audio, I don't know why it's not listed here. Or am I just missing it? Because as far as I know, audio is part of this. And it's not optional. It's probably just expands on the MSX1, because I think this had the same sound chip as the MSX1, which would make sense. Yeah, so still the same CPU, which is a Z80 at 3.5 megahertz. Pretty typical for Z80. By the way, this video display processor, or VDP for short, is totally an off-the-shelf component. I could have sworn that audio was part of this. Oh, here we go. Yeah. The AY38910 programmable sound generator. I'm fairly certain this was the same thing that was in the Specky. Need to double check on that. AY38912 was in the Specky. Oh, that was in the Spectrum 128, actually. Which I guess has 3-channel audio. Local host says, so somewhat better than C64 on video, a bit weaker than C64 on audio. I think so too. And the point of this sort of platform was that many hardware manufacturers could produce for this line and still be compatible and get like basically have access to the whole host of software. The reason why MSX came about, read a little bit on the history here, is the guy who ran the ASCII Corporation in Japan in the early 80s teamed up with Microsoft because what he basically noticed is that there was a sort of emerging computer market there, but because it was totally like fragmented and all the hardware manufacturers were doing their own thing, consumers were having a hard time like choosing a machine to buy, and he felt that was unnecessarily complicated. Remember that this also predated the IBM PC, so that whole like that standard wasn't a thing yet, and that was arguably a lot more successful. But yeah, this is kind of a predecessor to that style of things, as it were. Oh, interesting, Sophia. So they're basically the same, at least from as far as we're concerned. And yeah, you can expand the audio with a cart. These things were very expandable, as far as I understand. In fact, my machine actually has 2 cart slots, which is kind of cool. But yeah, they wanted to make a standard for, yeah, so you could actually have software that actually worked on multiple machines. And then the advantage of that from a hardware manufacturer standpoint is you wouldn't have to work so hard to get software houses to actually, work on your machine. So it's kind of a win-win in a lot of ways. Downside is you end up with a lot of machines that have less character, I suppose. But the nice thing is that like I can sit here and develop on this MSX. Someone else who wants to develop, like work on the same demo, can be developing on their machine, and it should all just work because it's all standardized hardware, which is kind of cool. Anyway, the different versions of the MSX standard that came out were just because things had to get better over time. That simple. And yeah, MSX2 in particular is what we're working with. So I think this became a standard in 85. And 85, and my particular machine is from 87. Which is pretty cool. And other than a new disk drive belt, it's all original as far as I can tell. Which is also pretty cool. So yeah, I think it's an interesting machine. I think it'll be kind of fun to code for. Particularly, I want to play with those block copy stuff, features of the video hardware. There's a really cool demo called Mocked by Spaceballs. Yeah, no worries, local hoster. I do not mind talking about hardware, so no need to apologize. I figured this won't be my most focused stream anyway. There's a demo called Mocked by Spaceballs. I don't want to sit here and watch the whole thing, but it's a really cool Amiga 500 demo. Like, really, really cool. Sorry if that was really loud, by the way. But it's got a lot of this, like, really sort of stylized rendering stuff. If you guys have seen anything recently by Spaceballs, particularly the stuff that Slummy and Luguber do, it doesn't look like A500 stuff. And it's usually dark, usually big and heavy and bassy. Really good stuff. And the way he did it is actually by basically drawing a bunch of blocks of graphics. And those blocks of graphics kind of mask another picture beneath them. I'm going to skip over a ton of details about this because there's actually a blog post about it if you check that Poet link. Really interesting stuff. Highly suggest you look into that. But anyway, I'm wondering if something like this could also work on MSX, which could be really cool. Yeah, Creekbot, me too. It's just a really cool demo. The skull on the end is just really sick. Mocked in Norwegian, by the way, is like force or power. So it's kind of a cool name. It's very cyberpunky indeed. So of course it says might. Yeah, might is in the sense like not I might do that, but he was mighty. That kind of might. And now that you mention it, that's probably a really good etymological common root that you're bringing light to, that I'm sure exists there. I only know because I work in at the same place as Slemmy, so he told me. Anyway. You know, I bet actually if I just grab the WLADX manual and I just start reading some of that. All right, well, actually, never mind. It's not going to give me any MSX specific information. It's just going to give me Z80 stuff. Excuse me. Yeah, this is, I think, what I need. Generic stuff. MSX assembly page. Put our MSX tech doc. Of course, it's going to be a 404 on some of these. The goal of the MEP is to be the ultimate source of information for the MSX programmer or programmer to be. Main target is assembly language because that's what the maintainer's preferred programming language is, but most information will be useful to other users of other languages as well. The MEP is currently maintained by Grauv. It's probably Dutch. Yeah, definitely Dutch because Donna and all. Articles contains. Yeah, I think this is probably where we want to be here. Future proof indeed. Let's check out articles. This is going to be the basic here. That kind of basic. VHDL. Oh, that's that VHDL. I don't know why that's in here. But okay. VTP programming tutorial. This will be really interesting in particular. Eventually. But not yet. One of the kind of annoying things about the system is that you can't directly access the VRAM. You have to go through the VDP, but that's pretty common, especially by this time. Yeah, it's just weird that VHDL would be in there, but okay. Okay. MSX BIOS calls, cool. Gonna want all that stuff. Oh, this all looks like really great information. Maybe I have to dig into like the MSX2 technical handbook. Oh, good point, local hoster. It might actually be Roy. Still kind of weird to see it, but yeah, you know. Okay, here's a bunch of stuff. Fader.asm. And some Dutch. Great. The reason why there's a lot of MSX stuff from the Netherlands is that Philips was a big manufacturer and distributor of MSX machines at the time. So totally not that surprised to see a lot of Dutch in here, to be honest. And that made sense. So what I'd be really interesting here, what I would be really interested in here is like finding some kind of build script for this. Because I want to know that given an assembler, like where does the memory need to be? Dark second? Thanks, man. I need to figure out like where in our memory map this code is sort of supposed to be loaded, how we actually jump into that. Like what is the basic command we need? So like how do we produce a binary of code, and then I'll just do like a main loop that increases a background color register or something to test. Where does that assembler code need to be assembled to? What is the format for the binary that comes out of there, and then how do we make sure that we can actually load that, and like what is the process from getting to from the BIOS to that? Those are all kind of things that we have to understand here before being any useful at this. So I'm hoping we can find some of that here. But I expect to just be doing a lot of digging around initially, which is fine. In fact, here we get like a system overview. That's probably going to be really useful. This Konami Man guy, by the way, has a ton of really cool MSX stuff. This is his like main page here. In fact, here's a Z80 course. Available in Spanish only. It's kind of funny. Oh, I love it. Love looking through this old stuff and just like not knowing how any of this works. I'll zoom in here, by the way. I don't really care too much about MSX1 versus MSX2 initially. It's going to matter a lot when we look at the hardware, but then we really just need to look at the MSX2 hardware, and that should just be it. Don't really care about what is MSX. Lots of stuff. Got a BIOS and ROM. We know that. Don't you speak Spanish, right? Nope. I know like 5 words of Spanish. That's about it. Lots of stuff. Okay, we're looking at the standards versus MSX1, MSX2. Actually, this is kind of a cool chart because you can see what's common and what's different. How common they're also words? I don't think they are. But usually those are the first words you learn in any language, if you learn it right. So actually, yeah, that could be. We got the MSX2 on the left here. Yeah, there's MSX-DOS format, which is based on MS-DOS, but not quite equivalent. Like if I format a disk in my MSX and then try and put it in this floppy drive, the USB floppy drive, it just eats shit. Totally doesn't work. But yeah. Yep, as basic, we're aware. Main ROM or extended ROM, as we've seen before. RAM size 64K. Oh, I know plenty of Norwegian swear words. Soundchip comes as VHDL. That's pretty rad. And I totally agree. It is an awesome way to save out of production hardware. At some point, I would love like all the Verilog files and stuff for like N64 to leak, just for preservation, because that would be so great to have. Dark Second, from what I remember, you can boot straight into an ASM program by writing into the boot sector of an MSX disk. Interesting. Didn't actually know that, but I would not be surprised. Be very similar to PC. Hey, Studio C. That may definitely come in handy. Yeah, in that case, it's probably going to load to a specific location in memory, and that's going to be determined by the BIOS. But it'll be standardized for sure. Skeleton, any reason to keep it closed off? Well, when it's new, of course. Episode 142, let's go on hardware. Oh, do not tempt me. At some point, we definitely will. I totally want to make an 8-bit computer in Verilog. I've done a few experiments with it and gotten like HDMI out of the particular FPGA that I have, so I'm totally interested in that. But yeah, I mean, it's one of those things like whether there's a reason or not to ever release that, they're not gonna do it because someone owns that IP. And there's tons of paperwork about, you know, legally whose that is and all that stuff. Like, Nintendo's not really a company known for saying, hey, here's all our old stuff from 20 years ago. So, you know. So I'm not sure what it means by the slot thing, but I guess we'll find out. Here we go. Memory map. 3 kinds of memory: main ROM, sub-ROM, and RAM. Each memory resides in an independent 64K address space. Cool, and is located as shown in figure 1.4. Each 64K space is called a slot. Okay, that's what a slot is. Which consists of 4 16K areas called pages. 1.3, 2, and 3 show memory usage when using MSX-DOS, basic MSX respectively. Was figure 1.3? Or was that? That's this one. I see. I see. Right, so these are our 64K areas in different slots. And I'm pretty sure it's showing us, I don't know if you're able to actually access different slots at the same time, or if you have to like map them in and out. I'm not really sure what this is showing us yet. Yeah, I'm not doing C. I want to do assembler. It'll be more to learn, but that's what I want to do. And really, it'll just be more to learn when we get started. like for actually doing demo effects, doing them in assembler is really not bad. CreekBot needs a Rust compiler. There's probably already LLVM backends for Z80, which would help. Okay, here we go. Main RAM memory map. Okay, no, this is actually just the like how the main RAM is actually allocated when you're using like the OS and stuff. These are just going to be, yeah, just allocated areas. But by the time we use this, none of this matters because we're just going to do whatever we need to with the memory. This is kind of cool though. Slot management control here. Interesting. MSX-DOS. Very interesting. So it might just be showing us like how these are banked in and out, which I would not be surprised. It says 1 and 3 are switched under certain circumstances, so to like bank these in and out. Because I'm pretty sure the Z80 can only address 64K of memory, and I'm pretty sure that's why you would end up with kind of a weird system like this. And so it's talking about these slots, but then I guess these different parts of the slots are visible under different circumstances. So I'm guessing there's going to be a little bit of memory mapping circuitry that we need to configure in order to do that. Interesting. Cool, DarkSecond. That'll be useful. DarkSecond just posted this. Small Hello World in Z80 assembler. Built entirely through cross-assembly and emulation. I'm going to get to this in a sec, actually, and keep reading this doc, I think, because I'm actually enjoying this. Even though it doesn't get us to the end goal as fast, it's just verbatim doing this. I kind of want to read this just because I'm enjoying it. Yeah, so 2 software environments, basic mode and DOS mode. Basic mode enables easy development and execution of MS program. This mode most often used by most users. Major reason why the use of personal computers has grown is it basically is easy to use. DOS mode enables various languages, utilities, and applications using MS-DOS, MSX-DOS. Basic and DOS use the same disk format. Okay, this is actually the end of this document. Where did this go? That's here. Let's skim these quick here. Because I would also kind of like to see why this is Org 4000. This also mentions this app make thing. And I'm kind of interested in what that is. Although, actually, now that I think about it, I actually would not be that surprised if WLA's linker had specific stuff for MSX. It tends to. In fact, this even mentions MSX here. Now, I already have WLA installed here. And in fact, here we have WLA Z80. But particularly, I need to pull up the manual. I'm totally gonna run that Zokwar. I'm tempted. Beep. Just a test. Didn't like that. Oh, 15 is max. Ah, nice. Bam. Thanks, Aqua. That was fun. I'm guessing all this is doing is just changing color. In fact, actually, it's probably the color for different parts of the system, just judging by this, particularly 115.1. Or, yeah, not sure. Anyway, where's this documentation for this? WLA link in particular is what we're after. Zucker says foreground, background, border. Good to know. Foreground, background, border. So there, okay. Foreground, background, border. Night mode. Yeah. Okay. There's some MSX Basic for y'all. But I totally don't remember where this WLA README was. Just go to README here. Yeah. Let's see MSX. Oh, that was it. Ah, I see. I'm actually going to look at this and see what that app make does. Is this not? So just by looking at this code, so but it's basically this org directive is going to say where it is in memory. This address I'm a little bit confused about because this is 64K and it's going to be above that somehow. May just be how it addresses the slot. I'm not actually sure. This is just a constant. Load HL, which is a 16-bit register formed by mixing H and L. I'll zoom in on this for you guys. With a pointer to the message, which is what this is. This can be hello world. I'm guessing this is the 2 line break characters. And then 0 to end the string. Because we have, MSS line endings. Screw that guy who rides a motorcycle outside my window. And then, call put S, which is going to be this little routine. And then ret, which probably just returns to basic. So put S here is just this little routine that he wrote. And in fact, this will just loop. Because here it returns. So it loads A with the byte at this offset. So it loads that into A. Or is it with A? Now I'm pretty sure all that's going to do is set the flags based on A, because if you take A or A, you'll get A. But then it'll probably set the flags because this is an arithmetic instruction. And then after that, it's going to ret Z. This is probably a conditional return on the 0 flag, which is what that's going to be, which would make sense here, because if it's going to be 0 here, then it's going to return, and then we'll get back here, and then this will return, and that'll be our exit condition. And then it's going to call chput, which is this thing here. And I'm guessing that's just going to be a specific address, which is like a standardized BIOS routine. Where you call a specific address and then you get that routine there. And then it's going to increment the pointer and then jump back here. That's what this program is doing. Darkscan, apparently the start, end, and execution address is in the file header. You're being quicker than me when looking for this stuff, which is nice. Descriptions of several file formats and types. Awesome. This is actually quite nice. Bin files are binary files and contain machine language. On disk, the structure is like this. We have the first 7 bytes of the file header. ID byte, start address, end address, and then execution address. It's at the end of the header here. Oh, yeah, that is what you said. Yeah. Start, end, and execution address is in the file header. Okay, that's what you meant. So you see, no interruption vector. You just load the pointer to the function. Yeah, that's often common on a lot of these older CPUs. It really depends, though. But I'm pretty sure Z80 didn't have interrupts as such, or you wouldn't have used them like that. That's kind of a thing that happened after in the 80s rather than in the 70s, which is when these CPUs are mostly from. And then you have the machine language. Note that this is only true for bin files on disk because cassette files have a separate header. So honestly, I think the easiest way to do this just to get something running is to just do this with the assembler, because I think that'll be actually pretty easy. I'm going to try that. And then we'll just steal this start address and see what happens. Let's do that. I need to look up a couple things here, though. I can look at one of my other make files to see how I invoke WLA for this. I think, can WLA just output bin files directly, or do I have to go through its linker? Because if I don't, that's actually ideal for now, and then I can worry about that later. I'm pretty sure it's going to have an option. Actually, let's just do this. Output object file or output library file. Okay, we probably actually do just have to output a object file and then link that, which is not too bad here. Not too bad to do that with WLA. So here's what we're going to do. I'm going to make a new file. And we're going to call this test.asm. In my make file here, we're just going to do, I'm actually not going to worry about variables and making this nice first. I'm just going to make it work. And then we'll deal with that in a second. So we'll do something like test.object. It's going to rely on test.asm. And for that, we're going to do WLA z80-o test.obj test.asm. Oh yeah, that's cool, Sophia. That's what I kind of find fun about the system, is kind of figuring out how that stuff works, and it's just nice. Here, we're going to do the typical things. In particular, we're going to take some of this. I'm fairly certain org in WLA is going to be .org, but I could be wrong about that. It's been a long time since I used WLA. Actually, not that long. Yeah, that's what it's probably going to be here. I'm totally looking at that SNES reference bars project, by the way, for this. And we're going to do a couple things here. Yeah, we're going to take that. Let's see if we don't need a section. I'm not actually sure if we do or not. We're going to do start adders here and adder, and then we're going to do the headers here. So here we're going to do something like, where did I put that piece of documentation? That was over here. So we need the ID byte, which is going to be FE here. So we can do this. And then we're going to have the start address. So I think it's going to be start adder and adder. And then the execution address. Which, yeah, may be different than these, but I'm guessing it's just going to be start adder again. Actually, we'll do this. And then that's even nicer, I think. Because then if we wanted to have other stuff in here and move this, we would be able to. Yeah, this is probably what we want. So there's a couple things we want to do with this. First of all, I want to more or less copy this code, actually. Let's do this. We need to change a bit of syntax here. A lot of this is going to be the same. That also, by the way, is supposed to be that, I think. Don't need comments here for that stuff. This is probably going to need to be something different as well. I'm guessing these are also going to need to be prefixed. Don't need the comments. I think, yeah, again, this defm thing we might need to call this something different. Let's see. Do .asc because we do want ASCII for sure. Something like that. Because. And I think this would look pretty good. Not too bad. Although this to me is kind of silly. Just saying. Or rather this. Actually, we can just do that. Done. So this should basically work. Let's see what this does if I just manually invoke this. Or actually, do make, because I did put that here, didn't I? No, I didn't, because we need the disk file to also rely on whatever our binary is. We'll do test.bin, which is going to rely on test.obj, and it's also going to rely on the linker script. And I'm pretty sure how I did this is... Yeah, we'll do the test.link. And for there, we're going to do WLA link. And we just give it the link script. And it's going to be put out test.bin. Our disk is also going to rely on test.bin. And from there, we'll at least see if this links and everything properly. We need to do a couple things like actually populate that link script. And then we'll adjust the auto start to actually run this. So the easy thing to do here, do test.link. And we'll do objects. And then this is going to be test.obj. I think that's all we need here. At that point, I should be able to do make. I'm going to bump up the font. Whoops. That's not it. Bump up the font size for you guys. Bloop. I think this stuff is just fun to set up here. No ASCII table defined. That's just a warning. That's fine. Here we go, though. Include directives, no ROM banks. ROM bank map wasn't defined. Now for this, I'm going to need a refresher here, I think. Think zero slot 1, bank 0 slot 1. Care too much about the particular Game Boy stuff because that's not really what we're interested in here. This is kind of nice to do the like accumulator 8 or 16-bit. Gonna be useful for 65C816. Although I think we just think it actually just can also auto detect the mode depending on the instructions. Don't need the ASM and end ASM thing. It's kind of cool. That's a random number generator in here. Yeah, indicates the size of the ROM in ROM banks. Values converted to a standard GB ROM size. This is a compulsory directive unless ROM bank map is defined. I'm kind of hoping we don't need to do some of this bank stuff. Just because some of this is not, like, we're not actually building a ROM. So I kind of want to look into a ROM bank map here. We could just try doing one bank. Let's try something here. Also, I think this is case insensitive. So insensitive. Sorry. So we can do this. Do one. We'll do the bank size. And I'll do one bank. Didn't like that. Okay, so maybe we have to do a bank size here. Let's do 64K. Overflows from bank 0. That's frustrating. Actually. Right, so we need to do this. We use org A for that, I think. Didn't like org A. Why not? Oh. I found some stuff here, it looks like. Although this is totally 6502. Yeah, VIC-20 memory config. But I think I can steal some stuff from there. I know I should sit down and like read through this a little more properly, but I'm kind of in the mood to just kind of hack this for now. That might be wrong. I think actually this needs to do that. This seems like this should actually be that. We'll see. Okay, that actually worked. And then this is WLA link. Not dash link. Here. So this was correct here, actually, which is cool. Although we got too large distance here, which is interesting. Also seems to be a bit odd. Because this should have fit in 8-bit between these two. That's a bit odd, actually. Also, what is this number in hex? To give me kind of a clue on what's going on here. 262153 negative. That's so weird. That's not the difference here. Yeah, I'm thinking so too. Look closer. 1 second here. I just Googled MSX2 memory map. Here's the Porter doc, by the way. Here's the whole slot thing again. I see. Yeah, so again, that's sort of banking these in and out. But I wonder... Here's our I/O ports. I just need to know where in ROM this needs to go. In fact, I think there was a user area here in the memory map. We could have just stuffed it in there, I think. It probably would have just worked. I want to see if there's better information in here. Yeah, RAM banking here. Because it really seems to me like we have these different areas in memory here, and they're through basically bank switching, we're going to be able to see different blocks of this size from the different like BIOS or BASIC or something else, depending on these different slots here. I think that's what this is telling me here. Now, interestingly enough, if that were the case, we had a user area here, which is at 8K hex. Yeah, dark second most I see is at 4,000. Yeah, so that's I think what I'm getting at here, and that makes sense. Now I would have guessed it would have been here, but we'll just see if this works. No, I think it's going to be this. I think that example that that Dark Second posted initially, which was on like Stack Overflow or whatever. Where was that? Here? I actually think this is probably just a typo now that I think about it. Now that we see a bunch that are at 4,000, this is probably just yeah, again, a typo. It's probably just this. And if that's the case, doing this should actually fix all of that. And in fact, that built for varying degrees of built. By the way, I'm going to fix this warning here, this ASCII table thing. I'm guessing oh yeah, you would have to do this. Meh. Or actually, we can just make a normal ASCII table and not put anything in it, I think. I'll get rid of that. Yeah, so that gets rid of the warning. Yeah, I was thinking that too, Studio C, but I'm going to try this here, and if that sucks, I'm going to try the 8K. Either the system's going to swap that for us, or something weird is going to happen. We're going to find out. We're going to find out. But at least this gives us something that builds, and from there we can kind of yeah. Like in bowling, we're gonna put in the bumpers. And we're gonna go for height and distance. That's how I bowl. I'm not a good bowler. Oftentimes when you write to where ROM is banked in, the write is either ignored or the write goes to RAM that was mapped underneath, depending on whatever. So we'll see what happens. I mean, the worst that's going to happen is we crash the emulator. The best that's going to happen is it works. So let's find out. Now that actually builds, we need to do a couple things. Particularly, we need to have that file in our disk. So in this disk command, or in this disk script here, we're going to import test.bin. And the other thing that we're going to do here is we want the auto exec to actually run this test.bin thing there. So instead of printing hello world, we're going to do this. I think it's bload test.bin, R. I don't remember what these do, but I see this. So I see this everywhere, so this probably works. And that seemed to have made the disk. And if I do make test, we might get hello world. didn't seem to do much. So it seems like it's running and then instantly returning, and I wonder why that is. Wonder why that is. We might need to run, but I'm pretty sure the B-load thing will actually run. In fact, I think that might be what that -R does. MSX basic B-load. Parameter R is used to run automatically the binary code contained in the loaded file. Yeah, so B-load is load binary. Then we get the file name, and then R is going to run it. That's what that is. So I don't think we need to run or jump into that, because I think that'll be taken care of by this if this worked. Just for kicks, I'm going to put that at 8K, and we're going to try this. Yeah, if that doesn't work, we have something else wrong, I think. Oh! Oh! What's up? Why did we get a syntax error there? But hey, this totally worked. So the fact that it printed hello world means that this actually worked. The fact that we had a syntax error in 10 is a little bit concerning, because why would we get that? Maybe it's because I did that. Let's just try that and see if that helps. Oh yeah, that's a good point. This should have shown us that. Or, no, yeah, you're right, that should have. Bam, yeah, weird stuff here. Files VDP Maxtron 28524. That sounds like an awesome transformer name. Let's just do a new line at the end of this. And I'm going to make sure my line endings are set to Windows line endings, because they have to be. We should get hello world, and then we still get a syntax error. I don't know why that is. Yeah. It's funny that it loads it, runs it properly, and then breaks. Isn't that weird? Here's a little disk manager editor thing. And I want to look in here and see if our disk is stupid. Oh, this is a big file. This is a 64K file. So it's probably loading a lot of data. And that's kind of why I was not too happy about doing the slots this way. I wonder if there's a way to make this smaller without being too silly here. So I also wouldn't be surprised if these values were not bounds checked. In fact, let's do this. Let's just take this down to like 1K. Or sorry, this is actually 4K, but 1K hex. And just see, because it could be that it like read 64K and wrapped around or did something weird like that. Okay, that's definitely not the problem there. Like this just eats crap after I do that too, which is kind of funny. We can look at the binary as well. In fact, if we go in here, test.bin, now 4K in size, which is good. So here we have our FE, which is our load thing there. 807 or 8007 is going to be our start adder. 8023 is going to be our end adder. Sounds about right. And 8007 is going to be our entry point again. That looks pretty good, given this was loaded into the right area. Oh, nice. DarkSecond found some more interesting WLA configuration stuff here. Bloop. Only slot 1 is used by this ROM from 4K to 7, whatever. Oh yeah, we actually got the different slots here as well. But default slot into 1. And yeah, the RAM here as well. Let's see what else this does. RAM variables, empty fill FF. Bank 0 slot 1. Puts into here. I think though, this should be fine here. We can do that as well. I mean, don't think that'll make any difference because I think that has to be which slot we're assembling into. But I honestly just wonder. This could be a number of different things. I mean, hell, it could even be like just bad stuff here. So like, let's do this. Let's just do something like this, and then we'll load it ourselves to see if it's any different. Yeah, I think those are RAM blocks for where it would put in its own, like its own work memory. So yeah, so now we get high here, and let's just do this. Like, let's do this. We'll do B. Actually, we'll do files. Make sure we have the right file. We can do bload test.bin R, and we get hello world. And if I list, you notice it corrupted again. So we must be right in basic memory or something for this to do this, because I think for it to get corrupted like this, it must have loaded a basic program and then loaded this right after that. So we must be loading this into basic memory or something. Because this is weird. Let's put this back, because I don't think that was the issue anymore. In fact, I think the new line didn't help either, which would make sense. Let's stick this here again. I think it didn't work, but let's see if that corrupts our basic program. I'm guessing it won't work, but it won't corrupt our basic either. Now if I list, we get this. And if I run this, nothing happens. Interestingly enough. We could also do something like put this at 9,000 hex, and just to see if it works and if we don't get the corruption. All right, so there it works, and yeah. Yeah, exactly, DarkSecond. So normally we wouldn't return from that, and so it wouldn't really matter. But yeah, I just kind of want to understand what's happening there. So I think that is what was happening, that the where we had the program aligned would be overlapped with our basic memory. So it would load this into memory and then load the binary and run it just fine. And then what it would do is it would get to the end of this line when we returned back to basic, and then would say, oh, there's a syntax error here. Not know how to handle that, which is fine. Yeah, so in this case, if I just offset that a little bit. So there's a bit more to look into here, and kind of figure out exactly where this memory map should be. The other resources on how to use these slots and banks are going to be useful as well. I need to actually sit down and just kind of read the difference between a slot and a bank and kind of how those are meant to be used, and get a better understanding of that as well. And also a better understanding of the memory map of the machine. But we totally got some code running. It actually does something useful, which is pretty cool. And I think I'm fairly satisfied with today. I'll probably clean this code up before I push it, but I do plan on doing a lot of these experiments in the open, even if they're not on stream. So if you guys want to keep an eye on what I'm doing or whatever, yeah, feel free. But yeah, I think I'm going to cut off the stream because it's already been 2 hours. But this is pretty fun, guys. Again, back to emulator stuff on Thursday, which will be, I hope, very exciting. We discovered some really interesting stuff last week when comparing dumps of our emulator versus Manafin. So I'm looking really forward to this Thursday where we get to dig into more detail about what's going on there. And then next week, maybe I'll do some more of this. Some guys were talking about blue noise, and I kind of want to play with some of that. So who knows? We'll figure it out. Anyway, this is pretty fun, and I will see you guys next time.